Welcome back, friends at home, to Level 3, the Crystal of Caution. In this section, we'll be examining exception handling. Well, what is an exception? Exception is a runtime error, and we need to distinguish a runtime error from a syntax error. So let's take a look at that. Here on the left, we've got some broken JavaScript in our alarm.js file. You can see we've got an alarm declared nicely with a nice string and a semicolon. We're good, but then we got this alert that's missing a right parentheses. This sort of syntax error will not even make it past the interpreter for the console. It will be marked as invalid JavaScript, and we'll get a little report back in the console to tell us that we did something sort of screwy. Over here, though, in alarm2.js, we have an alert call on an alarm variable with a closed up parentheses and a semicolon. We're all good there. The interpreter is going to think this is completely acceptable JavaScript, but then it's going to run and find that alarm has had no declaration by the time that that alert is reached. That is a runtime error, and it's the sort we want to catch in our code and then control once we have it. So we're going to scoot our runtime error over here, and we need to start thinking about what we can do about it. Well, we want to be thoughtful at all times about controlling program flow after runtime errors occur. And like other languages, JavaScript has a very unique mechanism for being able to find, catch, and recover from those errors as they occur. To start looking for errors in our code, the first thing we'll use is a try block. What's a try block? It's like a test zone for your code. It's like a stage that you can start running your code on, and it gets examined, and if errors come back, then we can catch those and do something about them. And if all goes smoothly here inside of our try block, and the global alarm variable happens to exist when it runs, then we're good to go. If something goes wrong in that try block, however, the try block will throw an error message containing details over to its very close buddy, the catch block. You see that the catch block has an error parameter, and as a parameter object within the catch block, that error can be used in any sort of messaging or even in conditions to take specific actions. What does this allow us to do as programmers? It allows us to have broken code exit more gracefully or take better action in the event of some error. Here you can see that if alarm did not exist, then we'll get a pop-up that says, uh-oh, and then it reveals that there was a reference error because alarm is not defined. The cool thing about errors is that there are multiple types of errors, which can allow us to take very specific informed action based on which type of error occurs. You want to use JavaScript's multiple error types in order to handle errors as gracefully as possible. Let's take a look at using some different error types by scooting down our code here. And inside of our try block now, we're going to establish a new Hall of Fame variable. And inside are going to be two new guys who are going to be added to the Knights Hall of Fame. We got Dask Frostring and Render Tallborn. Now let's say we wanted to add those new Hall of Fame guys to an existing list of Hall of Fame guys. But we would use the concat method, which would just put this array onto an existing array. Well, we hope that that array exists, right? What error types might we expect if this was our JavaScript file? Let's take a look. So let's say for some reason that list had not actually ever been defined yet, or that the master Hall of Fame had been redefined as something else in some other file. And if that's the case, when we try to access list to call a concat property on it, we're going to get a reference error. Additionally, if the list is not even an array or a string because maybe it had been overwritten by something, womp womp, then there won't be a concat method to actually call on the list, and so we will get a different kind of error called a type error. So say one of those errors actually occurred. Well, we need to plan for it inside of our catch block, which will get the error after the try block has thrown the error to it. So if the error that got thrown happens to be an instance of a reference error, then we'll alert a message that says, first the error, and then we'll say, the Hall of Fame roster does not exist as a list. Check for a relocation in the master document. That's giving us important information about what to do. It's giving us action to take, directing us as a developer if an error happens. But if the error happens to be a type error, right? Then we'll alert that error again, and this time we'll put a more informative message for the type error, which says, alas, the Halls list has no concat method, so please check for a disastrous overwrite. Since we know it's a type error, we know we probably don't got a concat there, which means that our list is very likely overwritten. So let's take a look at what happens in the first case when we would try to get a reference error. Well, we wouldn't try to get a reference error, but say it happened. We would redefine our list variable as being Hall. Let's say somewhere globally our list variable got redefined to be Hall. Whoop, there's all of our Hall of Fame existing inside of our Hall variable. Well, when that happens, we go to call list. Not there. We get a reference error and we get our pop-up back that says the Hall of Fame roster does not exist as list. Please check for a relocation in the master document. So that's the first kind, which is cool. We caught that error and we exited gracefully. Next, what happens if list is still there, but now it's a stupid number? It's 12. There are 12. List is 12. 12 is list. Well, when we get through that catch, we'll get a type error and we'll get the exact right pop-up message back. Object 12 has no method concat. Well, yes, no, it certainly doesn't. Alas, the Halls list has no concat method. Check for a disastrous overwrite. This particular error message sort of directs us exactly where to take action so that we're not left fumbling in the dark about where to start debugging. Now, we kind of hinted earlier at something that might happen here. What happens if list got rewritten to be a string? This code would run just fine because list, as a string, definitely has a concat method to call. The code would run just fine and it would avoid the catch block, but likely it wouldn't do it as expected. So let's check out what happens in that case. Well, down here we got 3 guys inside the Hall of Fame list that is now a string. Notice it's been formatted with some new line characters. And what we're trying to do to that now with the concat method is to put an array on the back end of that string. Let's see what happens. Well, the elements of the array get separated by a comma and get instantly added to the string. No space, no new line, nothing, just some weirdy addition of 2 guys to the back end of our list string. Yuck. So we probably need to do something about that in order to make sure that we don't have a string and in fact that we have an array. Here we go. The thing you want to take note of as a result of that string possibility is that JavaScript will not pinpoint every single error that could ever happen right inside your code. Instead, you want to use conditionals and the throw keyword in order to craft the right exception scenario based on what you think your code should do, which means you need to have a real intuitive knowledge of all the places that errors might occur in your environment of data. To illustrate how to use these throw keywords, let's go ahead and scoot our catch block down here and reformat our try block to really pinpoint errors on a better basis. The first conditional we've got here is just our standard. If the list happens to be undefined, then we'll go ahead and throw a new reference error. That means the list doesn't exist, but we're trying to concatenate on it later. So instead we throw a reference error as we did before. That's just the same thing that the try block did in our first instance. Next, we've got another conditional that first checks to see if the list is an instance of array. And if that's not true, meaning if it is false, then we will throw a new type error to the catch block. Now, it's important to note that as soon as the try block reaches any throw keyword anywhere, it will instantly stop what it's doing, take that error that it found, or that it's supposed to be throwing, and throw it to the catch block. And then the catch block will retain control of execution throughout the rest of the process. Something else we should do here, now that we've got our errors a little bit more pinpointed and correct, we should modify this final error message down at the bottom where it says, alas, the Halls list has no concat method. We should modify that. Let's try to make that more accurate. Since we got a more clearly defined problem up here, our program should be able to provide more accurate debugging information for all cases that we could expect. So now, if our Hall of Fame list was in fact a string for whatever reason, then we would get an error message that says, alas, list exists, but you know what? It's no longer an array, so please go and check to see in your debugging if somehow it got overwritten somewhere. It's important to note that it is our more clearly defined problem that has allowed us to have more accurate debugging instructions for all of the cases that we could conceivably expect in this case. So now, if we had a list that was a string instead of an array, we would get the error message exactly like we wanted. And now as we went back to correct our program somewhere in our JavaScript files, we would go to make sure that our list had not become suddenly a string, or modify this code to match the fact that it is a string. A cool extra thing about the try-catch block is that it has a secret friend called the finally block, which will allow us to take action regardless of any error that may have occurred inside the try block. If the try block executes smoothly, we'll go to the finally block. If the try block does not execute smoothly and we go to the catch block, after the catch block, we'll go to the finally block. The finally block just says we're going to do whatever is inside this block regardless of what happened before. So here you can see our finally block, which has got a console.log on the list in it, and that's going to execute whether try meets with success or failure. This is important because now we will know what list contained at the end of this execution. It may have been that we get all of the new guys added to the list, no problem, and this log will log out every last member of the Hall of Fame. Or we could get undefined if there is an error. Or we could get a string if it was a string. Or we could get that crazy number 12. But the point is that we are able to see what happened to the list variable, if anything. What if we wanted to try more than one option within our try-catch system? Well, nested try blocks, which are totally allowable, can be found within outer catch blocks so that if your first choice doesn't work, you may be able to try something else before you just gracefully exit on some error. Let's take a look at that. So we're going to build a new function here called change inner HTML by ID or existing, which is the longest function name known to man. And with that function, what we're going to do is look up some text element either by its current ID or by its existing inner HTML. And then we will update the inner HTML. Now here, our existing parameter is going to be optional. That's going to be just an extra search possibility in case the ID for the element we're looking for is not found. So now we've got our try block here inside, and in that we have a variable called new element, and we're going to set that equal to undefined. We're going to use that later if we need to make a new element. Following that, we're going to try to set the inner HTML of the element that we find with the ID to whatever the update is. In other words, if the element is found, we'll just update its inner HTML. Now for the errors. What happens if we catch an error from this? Well, the first thing we want to do is not exit the program or return a message or anything. We want to try something else. So we've got a try block that happens immediately after some error in our first try block has been caught. In this case, we may know the existing inner HTML instead of the node's ID, and it may have been passed in as an optional parameter, so we want to try searching based on the existing inner HTML. First thing we're going to do inside of our nested try block is we're going to get every last element of the document using that star inside getElement by tag name. We'll pass all those to an elements array, and then we'll search each of those elements for a matching inner HTML, and if we find a match, we'll change it and exit. Another cool thing we'll do is that since we don't have the ID variable, right, we couldn't find it, then what we're going to do is record whatever ID is at that text element inside our ID variable for later use. But inside of our loop, if we ever reach the end of that list, then the element location has failed and we need to do something. And what we'll do is we will throw a new custom error. That's right. In addition to all of those native JavaScript error types, we can create custom errors with all these custom message properties. And we're going to use that custom message property inside of our nested catch, which is upcoming. Now in our new nested catch block, you can see that our error parameter is called error2. That's because we want to distinguish it from the previous error. We need to give those two parameters, those two errors, different names for use in their blocks. What we'll do is we'll alert the message associated with error2, And we'll also tell the user that we are creating a new text node. That's because if no element was found with our existing inner HTML, or the ID in this case, then what we're going to do is we're going to make a new text node for use somewhere outside the function, and we're eventually going to return that value. Lastly, we will get to a finally block, and remember, the finally block is going to execute regardless of what happens in the try and catch nested blocks. Here you can see in our finally block that we check to see if the new element is no longer undefined. And if it's no longer undefined, what do we know? We know that we made a text node. But if new element was undefined, it means we did not create a new text node because it already existed, the one we were looking for. So what we do is we log out a notification that the requested element was updated, and what we'll do is we'll use either the ID if it exists, or the existing HTML that we found the element with. Notice our cool best practice of using default assignment to the existing if the ID was never found. So let's say in some website we called change inner HTML by ID or existing, and we called it with an ID of age. And let's say that that age ID did in fact exist. We also passed in an update, meaning we want the new inner HTML to be age is 35, and the old one, which was age, is 34. Well, what will happen in this case if age did in fact exist? First thing the function would do is go to its first try block, and it would find the element no problem and set the updated inner HTML to be age is 35, and we get that logged out. But what happens if age does not exist? Well, the first thing that happens is we go to the try block, and it doesn't work out because it never finds the element with that exact ID. So it'll throw an error, and it goes to the next catch block. Inside that catch block, we first go to a nested try. So it searches through all of the existing elements, but does in fact find an element that has an existing HTML of age 34. So what happens? We get a check and we roll all the way to the finally because we break out of the loop and don't need to go to the next nested catch block. Once we're in the finally block, we log out that we modified the element age 34, meaning we chose the existing label in our logical assignment with inner HTML age 35. So before, we chose the ID to log out because it was available, but in this case we're going to default to the existing inner HTML because the ID was not in fact available. And lastly, we look at the situation where age does not exist as an ID anywhere, nor does age 34 exist as some existing HTML. So now let's check out what happens on this run in this situation. The first thing we do is we hit the first try block, but there is no age ID anywhere. So we go to the catch block and we assemble all the elements, check them all out to see if there is an existing HTML that has age 34. There is not. And so when we don't find any element with that existing HTML, our new custom error is going to get thrown to the nested catch block. Then we will get a new message alerted that says, yo, an existing element was not found and we're creating a new text node. Then we will pass control to the finally block where when we discover that new element is no longer undefined, we will just log out that we are returning a new text node. And now you are so dangerous with, or maybe less dangerous with, try, catch, and error generation. So we will send you to some challenges where you get some work on protection and error generation.